What is TensorFlow? TensorFlow is a Python-friendly open source library for numerical computation that makes machine learning faster and easier. It uses Python to provide a convenient front-end API for building applications with the framework while executing those applications in a high-performance C++. TensorFlow supports CUDA, a parallel computing platform created by NVIDIA. It is flexible, scalable, and deployable. Computation graph. TensorFlow allows developers to create data flow graphs, structures that describe how data moves from a graph or a series of processing nodes. Each node in the graph represents a mathematical operation, and each connection or edge between the nodes is a multidimensional data array or tensor. What is a TensorFlow tensor? TensorFlow can represent a scalar or an 1D array or 2D matrix. What is the two-step programming pattern? TensorFlow is a two-step programming pattern. First step is to define a computation graph. Second step is to run the graph. TensorFlow API classes. Graph is a container for operations and tensors. Operations are the nodes in the graph. Operations represent computations. Tensors are the edges in the graph. Tensors represent data. Next we will see TensorFlow session. The graph is executed using tf.session and session.run commands. Run parts of the graph only. Suppose if you want to execute only this part of the graph or this part of the graph. The main advantages of TensorFlow is it allows to execute part of the graph. In this case, mul will get computed, but add will not be get computed. When session.run command is executed, first x and y are computed. Then op1 and op2 are computed. Then finally mul is computed. Running the whole graph. When session.run is executed, both mul and add are computed because of this command. Here both mul and add are computed based on this command. This way the whole graph also getting executed. Next is constants. tf.constant. A constant can be created using tf.constant function. It can be a scalar or 1D array or 2D matrix. It can be a scalar or 1D array or scalar matrix. It has arguments such as value. Value is a constant value or list, can be a list also, of output type, the D type. What is D type? The type of the elements of the resulting sensor. What is shape? Original, the optional dimensions of resulting tensor. Name, what is name? Name is optional name for the tensor. Next we will see variables. Creating variables. A variable can be created using tf.variable function, similar to a constant, can be a scalar or 1D array or 2D matrix. The preferred way of defining a variable is using tf.getVariable. tf.getVariable. This is the preferred way of defining a variable. And an initializer also required. Initializing variables. The variable in a graph can be loaded either by initializing or by restoring. The argument initial value is used to provide initial value to the variable. Optional name also can be given. When session.run invokes this initializer, the variable is getting initialized. Alternatively, tf.global underscore variables underscore initializer can be also used for initializing all the variables. This is for one variable, this is for all the variables. Next we will see how the data can be fed to the graph. There are two methods to feed data into the graph. One is using placeholders, another one is using dataset. How placeholder can be used? TensorFlow placeholders are initially empty and are used to feed the data during runtime. Initially, x is defined as a placeholder. Later, x is initialized with values 3 and 4 to session.run. Here you can see. We will see what is Tensorboard also. Tensorboard is used to visualize the graph. In this example, x and y variables are added and then z variable stored in the z variable. Tensorboard command has to be invoked from the command line. It requires two more arguments such as log directory and port, which need to be passed along with the Tensorboard command. This will provide an URL to visualize the graph. Copy this URL from command line and paste in Chrome browser. This can be visualized in the Chrome browser. So this is the command line. You can copy the URL from the command line and then paste in the browser. Then we can visualize the graph. So this is the sample graph which we can visualize. The graph can be visualized here. Next we will see how to save and restore the models. The ML model can be saved with the save command. So this is the command. The folder name and the model name need to be given. You can see here the folder name and then model name is given. How restore can be used to restore the variable model? The model can be retrieved using restore command. The respective folder name and model name need to be given. There is one example we'll see here. An example of TensorFlow program snippet is given here. You can see how the TensorFlow program looks like. So there is a train and a test variables are initialized from the Seifert and data. So then reshaping is done. Then mean values are computed. Then reshape, dimension got a reshape. Then these are all loaded. These variables are loading. X train, X test, Y train, Y test. Then the reshaping is done here. So one more batch it is taking. Then test data it is taking. So this is the way the TensorFlow program is written.